In an experiment, vagus nerve that innervates the heart was cut. In this video, we will discuss about what is the role and function of vagus nerve in this context, what is the effect on the heart rate, and how is the process involved for this to occur. Before that, there's a few things that we need to know. First of all, the heart is innervated by both the parasympathetic and sympathetic fibers. The medulla is the primary site in the brain that is responsible for regulating the sympathetic and parasympathetic outflow to the heart and blood vessels. Now we focus on the vagus nerve. The vagus is a mixed nerve that has a role in the sensory, motor, and secretory functions. It contains approximately 80% of sensory fibers. The vagus nerve has three nuclei in the central nervous system. These three nuclei is associated with cardiovascular control, in which these include the dorsal motor nucleus, the nucleus ambiguus, and also the solitary nucleus. Bear in mind that the parasympathetic output to the heart comes mainly from the neurons in the nucleus ambiguus, and to a lesser extent from the dorsal motor nucleus. Now, we would like to talk about the role and function of vagus nerve. The parasympathetic innervation of the heart is partially controlled by the vagus nerve and is shared by the thoracic ganglia. The parasympathetic fibers synapse at ganglia located directly on the heart, and short postsynaptic fibers and then supply the target organ. The parasympathetic nervous system mainly innervates the SA and AV nodes in the heart. Atrial muscle is also innervated by the vagal afferents, whereas the ventricular myocardium is only sparsely innervated by the vagal afferents.
Now the effect on heart rate. So I will show you the vagus nerve. This is the right vagus nerve and this is the left vagus nerve. They are connected to the heart. The vagus nerve mediates the parasympathetic innervation of the heart. The vagus nerve will innervate the SE node and lower the heart rate. Basically, if the BP is high, the efferent signal will be sent by the cardiac control center down to the vagus nerve via parasympathetic fibers and will innervate the SA node. These as well will lower the heart rate. It is important to note that the vagus nerve only mediates the parasympathetic innervation of the heart. But for sympathetic innervation of the heart, the cardiac nerve will take place.
Like other organs with dual innervation, the heart has a resting autonomic tone. Both autonomic divisions are normally active at a steady background level, releasing acetylcholine and norepinephrine at the nodes and into the myocardium. For this reason, cutting the vagus nerve, which is the parasympathetic division, increases the heart rate. Parasympathetic effects dominate in a healthy resting individual. Without autonomic innervation, the pacemaker cells of the sinoatrial node establish the heart rate at a rate of 80 to 100 beats per minute. At rest, a typical adult heart with normal innervation beats more slowly, at 70 to 80 beats per minute due to activity in the parasympathetic nerve innervating the sinoatrial node. The heart rate thus increases if parasympathetic activity decreases or if sympathetic activation occurs. The parasympathetic divisions, or the vagus nerve, alter the heart rate by changing the ionic permeabilities of cells in the conductive system. The most dramatic effects take place at the sinoatrial node by affecting the rate at which impulses are generated. Let's say the normal heart rate is 75 beats per minute. When the acetylcholine released by parasympathetic neurons opens chemically gated potassium channels in the plasma membrane, then potassium leaves the nodal cells, dramatically slowing their rate of spontaneous depolarization and also slightly extending their duration of repolarization, causing the hyperpolarization. As a result, this increases the time required for these cells to reach threshold and heart rate declines. In contrast, if the vagus nerve is cut, there is no parasympathetic stimulation and hence heart rate increase. This means there is reduced repolarization and more rapid depolarization. With that, we end our presentation. Thank you.